Alright, so let's say you're given this diagram of a guy hanging from a rope, and they ask you, what is the weight force and what is the force of the tension? Could you answer? If not, continue watching this video. So to start, we need to identify that the object, which is the person hanging, is in equilibrium. But what does this mean? An object is said to be in equilibrium if it is at rest or moving with a constant velocity. So for our situation, the guy's at rest. The essential physics principle that applies to objects in equilibrium is Newton's first law, which the equation for this is given below. Summation F on the left-hand side, that just means the sum of all forces, it has to be equal to 0 for an object to be in equilibrium. Now we can break this down into components, the sum of the forces in the X and the sum of the forces in the Y. You can bring this back to our example. First thing to do is draw free body diagrams, which for the free body diagram, we need to identify all the forces acting on the object, which is our person. So we can draw the mass and we can draw the weight force and the tension force. These are the only two forces working on the object. You can draw a coordinate system, the X and Y. Remember what we're looking for. We need the weight and the tension force. Both these forces in the Y direction. So we're going to be using the Newton's first law in the Y direction equation. First, we can find the force of the weight, which is just equal to mass times gravity. So if we plug in our mass equal to 5 kilograms and then the acceleration due to gravity equal to 9.8 meters per second squared, and we multiply them, we get 49 newtons for the final answer. So this is going to be the force of the weight due to gravity. And now we can find the tension force. So we have to use the summation of F of Y equal to 0. So get our free body diagram. We can see that the tension force is pointing in the positive direction and the weight force is pointing in the negative direction. So we can take the summation of these forces by doing T minus W. If we plug in our value for weight, we get this expression here. Then we can bring the 49 newtons to the other side and it becomes positive, and we get this for the final answer. So this is going to be the force due to tension in the rope. And this result makes sense because we look back at our diagram here, the forces cancel out, leaving him in the same position in the air, which means he's in equilibrium.